Most of us move through ordinary days with a quiet assumption in the background that our experience is something that turns on in the morning and at the end of life turns off permanently. It is such a common assumption that we rarely notice it. We plan our lives around it. We build our fears and our courage around it. And in countless stories, rituals, and private conversations, human culture has treated death as an irreversible boundary, a one-way door, a final line that cannot be crossed back over. From a traditional scientific perspective, this makes sense. Biology describes life as an organized process, cells maintaining themselves, brains coordinating the body, networks of neurons producing the patterns we associate with memory, personality, and awareness. And death, in that same framework, is the shutdown of those processes, the end of circulation, the end of oxygen delivery, the loss of coordinated brain activity. A system no longer able to sustain its own order. In that story, consciousness is what the brain does, and when the brain stops, experience stops. But late at night, when the world is quiet, some questions return, not as drama, but as gentle pressure. Because physics, the most fundamental science we have for describing reality, has been teaching us for more than a century that the universe does not always behave the way our everyday intuitions expect. Matter can act like waves. Events can be linked in ways that resist simple classical explanation, and the act of measurement itself can be strangely difficult to separate from what is measured. Quantum mechanics, in particular, challenges the comfortable idea that the universe is simply out there, fully defined, whether anyone looks or not. Now, to be clear, quantum physics does not say that human thoughts create reality in any simple way. Most working physicists are careful about that. Still, quantum theory forces us to take observation seriously, not in a mystical sense, but in a technical sense. Because what we can say about a system depends on how it is probed, how it interacts, how information becomes definite. And in that quiet space, between what exists and what can be known, some scientists and philosophers have wondered, carefully and often privately, whether consciousness interacts with physical reality in deeper ways than we currently understand. Not as a proven fact, not as a confident conclusion, more like a persistent question at the edge of the map. Which brings us to the calm, unsettling possibility at the center of tonight's journey. What if death is not the end of experience? What if it is not a hard stop, but a kind of transition, or in a very specific sense, a reset? This is not a claim, it is not a promise. It is a scientific curiosity, an exploration of how far our best ideas can stretch before they tear, or transform into something new. Because if consciousness is deeply connected to the structure of the universe, even in ways we do not yet have language for, then death may not behave exactly the way we expect. The boundary between life and death, so sharp in our stories, might be less clear than it appears, not emotionally, but physically, in the underlying rules that govern information, time, and identity. Over the rest of our slow walk through this question, we will start with the ordinary grounded definitions. We will look at how scientists define life and death biologically, what counts as a living process, and what it means medically and physically for that process to end. Then we will move into something stranger, but still scientific, the physics of information, and why some physicists take seriously the idea that information is not easily destroyed, even when the forms that carry it are. We will look at consciousness carefully, not as a magical substance, but as a phenomenon that may relate to how systems integrate information, and how observers fit into the physical description of the world. We will also touch the quantum theories that challenge our understanding of observation, and what it means for an event to become real in a particular way, to a particular system. And we will widen the lens further toward cosmic ideas about time, memory, and identity, asking what it even means to be the same self across moments, and whether the universe has room for patterns to reappear, for information to be recycled, not as reincarnation in a cultural sense, but as a question about how reality stores what happens. If you enjoy calm, thoughtful trips like this, you can like the video and subscribe to the Sleepy Cosmos channel. It helps the channel grow, and it keeps you close to these quiet explorations of strange scientific questions. Because the more carefully we look, the more we notice an eerie tension between the simplicity of the everyday story and the strange depth of the physical one. And to understand why some scientists have even considered such strange possibilities, we first have to begin with the ordinary scientific story of what death is supposed to be. In biology, the word life is not defined by a single magic ingredient. It is described by a collection of measurable behaviors, patterns that can be observed, tested, and compared. A living system takes in energy, uses it, and releases waste and heat. That steady flow is metabolism, a kind of chemical bookkeeping. Food becomes fuel, fuel becomes movement, repair, growth, and also heat that drifts away into the surrounding air. At the smallest scale, that story happens inside cells. And the cell is one of biology's most reliable landmarks. A living cell is not just a bag of chemicals. It is a structured, active environment, with membranes that separate inside from outside, with molecular machines that copy, cut, fold, and transport, with signals that tell different parts of the cell when to speed up and when to slow down. And the most important part is that it keeps doing this, moment after moment, not by accident, but through regulated activity. That ongoing activity matters because the universe has a general tendency, a gentle but relentless drift, from ordered states into more disordered ones. In everyday terms, things fall apart more easily than they come together. A hot drink cools down, a tidy room becomes messy, a complex structure left alone will eventually break. In physics, we often summarize that tendency with the concept of entropy, a measure, in broad terms, of how spread out energy is, and how many microscopic arrangements can produce the same overall state. Higher entropy means energy is more dispersed, more evenly shared, less able to do organized work. Living systems are unusual because they push back against that drift, locally, for a while. They build and maintain structure. They keep concentrations where concentrations are unlikely. They preserve boundaries. They keep delicate chemical balances. They do this by spending energy, constantly. Life does not violate the second law of thermodynamics. It pays for its order by increasing disorder elsewhere. You stay warm by releasing heat. You stay alive by consuming fuel and producing waste and radiating energy out into the world. This is homeostasis, the ability to maintain internal stability even while the outside changes. Body temperature, blood sugar, salt balance, the acidity of fluids, oxygen levels, pressure, all kept within narrow ranges. Not perfectly, but close enough and long enough for complex processes to continue. Homeostasis is one of the clearest signatures of life because it shows active control, not just motion, not just chemistry, but regulation. And underneath metabolism and homeostasis, there is something else that biology leans on heavily: networks. Not a single pathway, but many pathways layered together, like a city at night viewed from above. Signals cross signals, feedback loops correct errors. One molecule activates another, which blocks a third, which triggers a repair process, which calms the original signal. These biochemical networks are deeply interdependent, and that interdependence is part of their strength and also part of their fragility. Because when enough links fail, the whole pattern can collapse. So biologically, life is this organized persistence, a sustained pattern of controlled chemistry, balanced on a continuous supply of energy. Resisting entropy, one moment at a time. Now, what about death? In medicine, death is not defined as a philosophical idea. It is defined as a clinical state, a determination that the organism has permanently lost the functions that keep it integrated as a whole. In the past, the most common practical signs were simple: no breathing, no heartbeat, no pulse. But modern medicine complicated that picture, because machines can support breathing, and medications and devices can sometimes restart a heart. So the definition had to become more precise and more careful, especially in hospitals. Today, in many countries, death can be determined in two primary ways: either by the permanent cessation of circulation and breathing, or by the permanent cessation of all function of the entire brain. That second one is what people usually mean by brain death. Brain death is not the same thing as being in a coma, and it is not the same thing as a vegetative state. Those conditions can involve severe impairment, sometimes devastating impairment, but still with some brain activity, some preserved functions, sometimes even cycles of sleep and wakefulness. Brain death is different. It refers to an irreversible loss of the brain's ability to function at all, including the brainstem, which controls basic reflexes and the drive to breathe. Clinicians test for this carefully. They look for unresponsive coma, no purposeful response to pain, no brainstem reflexes, no gag reflex, no pupil response to light, no eye movements that should occur when the head is turned. And one of the most important tests is whether the person can breathe on their own when carbon dioxide rises in the blood, a rise that normally triggers an automatic breath. If there is no attempt to breathe, even when the body is strongly signaled to do so, that suggests the brainstem is no longer functioning. In some cases, additional tests are used, tests that look for electrical activity or blood flow to the brain or other confirmatory signs, depending on the medical setting and the local standards. And then, crucially, doctors consider irreversibility. Whether the cause of the condition is known, whether it is sufficient to explain the loss of function, and whether confounding factors have been ruled out. For example, extreme cold can slow the body so much that signs of life become faint. Certain drugs can suppress reflexes. Severe metabolic disturbances can mimic profound brain dysfunction. So medicine tries to be cautious because the line matters. When medicine declares death, it is saying something very specific. Not that the body has no chemistry left, but that the integrated control system has ended and will not return. The organism as a coordinated whole has stopped. Now we come to the brain, because in the ordinary scientific story, the brain is the central piece of the puzzle. The brain is made of neurons, cells specialized for signaling. A neuron maintains an electrical difference across its membrane, like a charged boundary. When it is triggered, it produces a rapid electrical change, an impulse that travels along the neuron and then influences other neurons across tiny junctions. Those junctions can be electrical, but often they are chemical, with neurotransmitters released into a microscopic gap, binding to receptors and changing the next neuron's likelihood of firing. When you scale that up, you get patterns, rhythms, waves of coordinated activity, networks that can synchronize and then desynchronize, depending on what you are doing, what you are sensing, what you are remembering, what you are feeling. This electrical activity is not a side effect. It is part of the brain's working language, and it is tightly tied to blood flow and metabolism, because active neurons consume energy, and that energy must be delivered constantly. If oxygen and glucose are interrupted for long, neural activity falters and the cells begin to fail. From the perspective of mainstream neuroscience, consciousness is strongly linked to these living, active networks. There are different theories, and scientists debate the details, but many approaches share a family resemblance. Conscious experience is often treated as emergent, not as a separate substance poured into the brain, but as a property that arises when matter is organized in certain complex ways, with specific kinds of information processing, integration, feedback, and coordination across many parts of the system. In plain terms, the idea is that a single neuron is not conscious, but a brain-wide pattern might be. Not because of magic, but because the pattern has the ability to represent the world, model possibilities, hold a stable point of view, and update itself. And there's a very practical reason this view has been persuasive. When brain activity changes, experience changes. If you alter brain chemistry with anesthesia, subjective experience fades, often into blankness. If you stimulate certain regions electrically, people report flashes of memory, or sensations, or movements. If a stroke damages a specific area, a specific ability can disappear. Language, face recognition, the sense of body position, the capacity to form new memories. If the visual cortex is damaged, the world may no longer arrive as images. If the auditory system is disrupted, sound can vanish. The mapping between physical brain states and mental states is not perfect, and there are still mysteries, but the link is strong. So the traditional scientific assumption, sometimes called a materialist view of mind, treats consciousness as something the brain does. The brain is not thought of as a receiver of a separate signal, but as the generator, the producer. Under that model, when the brain's organized activity stops, experience stops. No continued viewpoint, no continued awareness, because the physical process that supports awareness has ended. And this is not just a philosophical preference. It is tied to decades of experiments, clinical observations, and technological measurements. When the brain is deeply suppressed, reports of experience generally decrease. When the brain is active in certain ways, reports of experience return. When the brain is damaged, specific parts of the mind can be predictably altered. This consistency is one of the reasons the model has dominated neuroscience. It works. It is testable. It connects to biology, chemistry, and physics. It allows careful predictions, and it has supported real medical progress. Now, in the same steady scientific spirit, we can place death into thermodynamics, the physics of energy and change. Entropy, again, is a way of talking about the drift toward equilibrium. Equilibrium is what happens when there are no longer useful gradients. No concentrated pockets of energy, no strong differences that can drive organized motion. A living body is full of gradients, high-energy molecules next to lower-energy products, salt differences across membranes, electric potentials, oxygen-rich blood moving toward oxygen-poor tissues. These differences are like tiny waterfalls, and the body is built to harvest them. But those gradients do not maintain themselves. They are maintained by continuous work and continuous energy input. When the input ends, the work ends. Pumps stop, membranes lose their careful separation. Chemistry drifts towards simpler states. Temperature equalizes with the environment. The body, as an organized system, begins to move toward thermodynamic equilibrium. In that sense, death can be described as the end of active resistance, the end of the organized struggle against entropy, and the beginning of a quiet return to the default direction of physics. And when you put all these pieces together, the model feels complete. Life is organized chemistry, maintained by energy flow, guided by networks of regulation. Consciousness is a function of a living brain, emerging from coordinated electrical activity. Death is the irreversible loss of that activity, followed by the gradual dissolution of the body's fine structure, as entropy takes its calm, ordinary course. It is logically satisfying, because each part supports the next. It is experimentally grounded, because the link between brain activity and awareness is supported by strong evidence. It is the explanation most scientists consider correct, because it makes clear predictions, and because it fits smoothly into the larger structure of biology and physics. And if the story ended here, it would be neat, almost too neat, like a puzzle with every piece in place. But beneath this stable picture, there are a few strange scientific details that refuse to sit comfortably within it. And it is worth lingering in that neatness for a moment, because the comfort of the model is not an illusion. It is built from many layers of careful work, and it has earned its place. When a heart stops, blood no longer carries oxygen to the brain. Within minutes, the brain's energy balance begins to fail. Not as an abstract concept, but as a practical, measurable shortage. Neurons are demanding cells. They spend energy constantly just to maintain their electrical readiness. Even at rest, when that maintenance collapses, signals become disorganized, then silent. And in the hospital, this is not guessed at. It is monitored through breathing patterns, reflex tests, blood gases, brain imaging in some cases, and the clinical story of what happened. A massive injury, a long period without oxygen, a catastrophic bleed. Medicine does not treat death as a mood or an impression, but as a threshold crossed when the systems that can bring someone back no longer can. The word irreversible sits quietly at the center of it all, not as poetry, but as an operational requirement. Irreversible means, even if we do everything we know how to do, the integrated function will not return. And when that is true, the biological account says something very plain. The self, as an ongoing process, has ended. This is also why the materialist view feels so steady, because it is supported by a kind of ruthless consistency. You can alter conscious experience with predictable interventions. You can reduce it with anesthetic gases, with certain sedatives, with carefully controlled cooling. You can fragment it with seizures that disrupt coordinated networks. You can distort it with lesions that remove pieces of perception or pieces of memory or pieces of emotion. And you can sometimes bring it back when circulation is restored quickly, when oxygen returns in time, when swelling is controlled, when the chemistry of the blood is corrected. Again and again, awareness follows function. Subjectivity follows physiology, not perfectly, not in a way that answers every philosophical question, but enough that, in laboratories and clinics, the simplest working assumption has been, the brain is doing the mind. So when the brain can no longer do that work, the default conclusion is that there is no experience left to speak of. not hidden, not waiting, just absent. Like a flame when the fuel is gone. And then the larger physical picture closes around the body. Energy gradients fade, chemical potentials flatten, the ordered, maintained separations inside and outside, high concentration and low charged membrane and neutral fluid, begin to lose their sharpness. What was once held in place by constant work becomes free to drift. This is one reason entropy is such a useful word here, even if it can sound distant and mathematical. In plain language, entropy describes the tendency for differences to even out, for organized arrangements to become more statistically common arrangements, for the special to become the typical, unless energy is spent to keep things special. A living body is special in that sense, a very narrow arrangement persisting against what is easy. Death, in the thermodynamic framing, is not a punishment or a verdict. It is what happens when the paying stops. And physics takes the ordinary path. And once you see the story this way, it can feel almost complete enough to rest inside. Life, a pattern of regulated chemistry, built from networks, maintained by energy. Mind, an emergent property of active neural organization, tied to measurable electrical and metabolic activity. Death, the end of integrated function. The irreversible silence of that organization, followed by the slow return of structure to equilibrium. Many scientists accept this not because it is cold, but because it is coherent. Because it matches what experiments can manipulate, what injuries can damage, what medicines can suppress, what machines can temporarily replace, and what, at a certain point, nothing can restore. It is also a model with practical moral weight, because it shapes how we decide to intervene. When to resuscitate, when to stop, how to define donation, how to tell a family the hardest kind of truth. So yes, as a scientific framework, it feels solid. It feels like the kind of explanation that would be final. And still, even in mainstream research, even in clinical literature, even in careful physics, there are a few observations, quietly recorded, not always well understood, that give this tidy picture a slightly uneven edge. Not enough to overthrow it, but enough to make a thoughtful person pause and look more closely. Because beneath this stable picture, there are a few strange scientific details that refuse to sit comfortably within it. One of those details begins with a word that sounds almost too confident: information. In everyday life, we treat information like something soft, a story in a notebook, a photograph on a phone, a name remembered, a secret forgotten. It can feel like it comes and goes, as easily as attention. But in physics, information is not only a human idea, it is tied to the actual arrangement of matter and energy, to what is knowable, in principle, about a system. And this is where a quiet, persistent principle enters, the idea that information cannot simply disappear. Not in the sense that you personally can always recover it, not in the sense that every detail stays neatly accessible, but in the deeper sense that the universe does not like to erase. In many areas of physics, when something seems to be destroyed, it is often only being scrambled. It is being dispersed, spread into correlations, diffused into heat, hidden in places that are difficult to track, but not cleanly removed from reality. This is sometimes described as information conservation, a cautious phrase, because the exact meaning depends on which part of physics you are using and which assumptions you are allowed to make. Still, the underlying intuition shows up again and again, and it tends to create a certain kind of unease, because it suggests that the past is not truly gone, it is only complicated. In thermodynamics, we talk about entropy, about the tendency of organized differences to flatten out. A warm cup of tea cools, a drop of dye spreads through water, a room becomes uniformly the same temperature. And once those differences have spread, it is extraordinarily hard to reverse them. Not because it is forbidden in a strict logical sense, but because the number of ways to be mixed is so much larger than the number of ways to be neatly separated. The information about the earlier state, the sharp boundary between hot and cold, between dyed and clear, has not necessarily been annihilated. It has been distributed into microscopic details, the exact positions and motions of countless molecules, details you do not measure and cannot realistically control. So to you, it looks like the information is lost. But to the underlying physics, if you had perfect knowledge and perfect control, the story could, in principle, be unwound. That is one of the strange features of the microscopic laws. They often run both ways. Time feels one-directional to us, but the equations beneath many everyday processes do not obviously contain an arrow labeled past and future. The arrow comes from statistics, from scale, from the practical reality of enormous numbers of particles, and then quantum physics adds its own layer. In quantum theory, the evolution of an isolated system is typically described as reversible, not in a casual sense, but as a kind of precise bookkeeping. Even when measurements enter the story, even when outcomes look random, the broader framework is famously reluctant to admit true erasure. This reluctance becomes especially vivid in the discussion of black holes, where physicists have argued for decades about whether information is lost or preserved in some subtle form. You do not need the details tonight, only the tone of the debate. Some of the most careful minds in physics have treated the possibility of information loss as a deep problem, not a minor technicality. Because if information can vanish, then the universe has a kind of forgetfulness built into its foundation. And if information cannot vanish, then even events that look final may leave traces that are, in some sense, still part of the world. Now, bring that idea back down to the scale of a human life. The brain is matter, organized in a very particular way. It is not just a lump of tissue. It is a layered, living network filled with cells that communicate through electrochemical signals, cells that change their connections, adjust their sensitivities, strengthen and weaken pathways, depending on what you have experienced. When you learn something, the brain does not store it like a sentence on a page. It stores it like a pattern, spread across many regions. Some memories are encoded in the strengths of synapses, the tiny junctions where neurons influence one another. Some are stored in the tendency of certain groups of neurons to activate together, to form a stable loop. Some are reinforced by repeated use, becoming more easily triggered, more readily reconstructed. Even when you recall a memory, you are not simply retrieving it unchanged, you are rebuilding it, using networks that are active in the present, guided by traces of the past. Thoughts, too, are not single objects, but dynamic configurations. Electrical rhythms, chemical gradients, predictive models the brain is continuously generating and correcting as it tries to keep a body alive in a world that never stops changing. In a scientific sense, your identity is not located in one neuron or one chemical. It is distributed like a song that exists in the coordinated motion of many instruments. And that makes the brain, very plainly, an information processing system. It takes in signals, compresses them, categorizes them, attaches emotional meaning, stores some pieces, throws away others, and uses what remains to guide action. This is not a metaphor. It is a physical process, built from atoms, built from energy flows, built from structures that can be measured. So the question returns, gently but insistently. When the brain stops, what happens to the information that was being carried in that organization? We know what happens to a lot of the energy. It becomes heat, it spreads into the environment, it becomes part of the ordinary thermodynamic story. We know what happens to the matter. It remains matter, rearranged by chemistry, returned eventually to wider cycles. But the information, the specific patterns that made you recognizably you, the fine structure of connections, the learned expectations, the private library of memories, does that information simply vanish? Or does it persist in some dispersed, scrambled, practically unrecoverable form, the way the tea was once hot persists in the microscopic details of the room? For mainstream neuroscience, the practical answer is straightforward. Once the organized activity is gone, once the structure begins to degrade, the functional information is no longer usable. It is not performing computations. It is not generating experience. It is not available to any organism. In that sense, it is gone. And yet physics quietly whispers, gone may not mean erased. Gone may mean diffused. Now, if that were the only anomaly, it would remain an abstract one, interesting but remote, a puzzle you can place on a shelf. But there is another category of observations, recorded not in particle detectors but in hospital rooms and in careful interviews, that some people find difficult to fit into the neatest version of the biological model. Near-death experiences. These are reports from people who were close to death, or believed themselves to be, sometimes during cardiac arrest, sometimes during trauma, sometimes during severe blood loss, sometimes during complications of surgery. The common features are well known: a sense of separation from the body, a feeling of moving through darkness, encounters with bright light, intense emotions of peace, a panoramic review of life events, a strange clarity, sometimes the sense of hearing conversations or seeing details of the medical environment. Not every account contains these elements, and many accounts differ, but the pattern is recognizable enough that researchers have tried to study it systematically. There are prospective studies where hospitals attempt to document what patients report and when and under what physiological conditions. There are standardized questionnaires to separate cultural expectation from consistent features. There are debates about how often these reports occur and how reliable they are. This is not only folklore, it is also messy data. Mainstream explanations tend to focus on the brain under extreme stress. A brain deprived of oxygen can produce tunnel vision, disorganized firing, and altered time perception. Certain neurotransmitters may surge, including chemicals involved in dreaming, in pain control, in dissociation. The boundary between internal imagery and external reality can blur, especially when sensory input is disrupted. Anesthesia awareness, partial sedation, and the strange transitions between consciousness and unconsciousness can create vivid, confusable experiences. The temporal ordering is also tricky, because a person may form memories during the period of recovery, then later associate them with the time when their heart was stopped. In other words, the brain may generate the experience as it is coming back online and then narrate it as if it occurred during the blankest part. All of these are plausible. Some are strongly supported by what we know about perception and memory. And still, the mystery does not fully dissolve, because some reports include details, accurate details, that appear, at least on the surface, difficult to explain by ordinary sensory pathways. Not always, not consistently, not in a way that settles the matter. Sometimes these stories do not survive careful checking. Sometimes they do, but still have possible explanations. A snippet overheard earlier, a guess that happened to fit, information reconstructed after the fact. Yet the overall phenomenon remains stubborn, not as proof of anything supernatural, but as a reminder that consciousness at the edge of death can behave in ways that are not yet completely mapped. The brain, even in breakdown, may have modes we do not fully understand. And that brings us to another quiet corner of research, one that sounds almost like it belongs in the wrong building: quantum questions in biology. For a long time, the default assumption was that quantum effects, the delicate coherence and interference seen in physics labs, would not survive in warm, wet, noisy biological tissue. They would be destroyed too quickly, washed out by thermal motion. In many cases, that is still the best assumption. But over the past few decades, there has been emerging research suggesting that, in certain biological systems, quantum effects may play functional roles. Photosynthesis, for example, shows signs of highly efficient energy transport that some models describe using quantum-like coherence. Certain enzymes may rely on quantum tunneling, where particles cross barriers in ways classical physics would not allow, helping reactions occur at the speeds life requires. Some researchers have explored whether animal navigation in certain species might involve quantum sensitivity to magnetic fields, though the details remain under active study. None of this proves anything about the mind, but it changes the atmosphere slightly. It shows that biology is not automatically disqualified from using quantum phenomena. And once that door is cracked open, some people have asked, carefully, and sometimes controversially, whether any quantum effects could matter in the brain. Here we need to be very calm and very precise. The mainstream position is skeptical. Neural signaling can be described quite well, using classical electrophysiology and chemistry. The brain is warm, noisy, and full of interactions that would tend to destroy quantum coherence rapidly. So most neuroscientists do not think your thoughts are quantum computations in any direct sense. Still, there are hypotheses. Some propose that tiny structures inside neurons might support brief, localized coherence. Others suggest that quantum randomness at molecular scales could influence neural outcomes in a way that becomes amplified. And some theories attempt to connect quantum measurement problems to conscious observation, though these ideas are not widely accepted and are often criticized for being vague or untestable. It is important to say it clearly: This area is controversial. Intriguing, yes, but not established. Yet even the existence of the conversation is a sign of something. It suggests that we are not fully satisfied, that we do not yet have a complete bridge from the smallest physical description to the lived experience of being a person. Which brings us, very gently, to the most persistent puzzle of all. The puzzle of conscious awareness itself. Neuroscience has mapped a great deal. We can correlate experiences with brain states with impressive precision. We can identify networks involved in attention, in memory, in language, in emotion, in self-referential thought. We can watch patterns change when someone falls asleep, when they wake, when they dream. We can sometimes predict what a person is seeing from activity in visual regions. We can tell when someone is likely to respond, even when they cannot speak. All of this is real progress, and yet there is still a gap between description and feeling, between the measurable activity and the fact that there is something it is like to be the one having the activity. This gap is often called the hard problem of consciousness, a philosophical label for a scientific discomfort. Why should any physical process, no matter how complex, come with an inner point of view? Why is there a private theater at all? You can describe color vision as wavelengths and neural codes and still not explain why red feels like red. You can describe pain as nerve signals and protective behavior and still not explain why it hurts. You can map the brain in exquisite detail and still find yourself staring at a diagram, wondering where the experience is hiding. Many researchers believe the hard problem will soften as theories improve, as we understand integration, attention, prediction, and memory more deeply. Others suspect the gap is telling us something fundamental, that subjective awareness is not easily reducible to the usual categories. Not magic, not mysticism, but a sign that our conceptual toolkit is incomplete. And this matters tonight, because if we do not fully understand what consciousness is, then we should be careful about declaring, with total confidence, what happens to it. When the brain crosses a threshold we call death. The biological model remains strong, but along its edges we find these anomalies. The persistence of information in physics, the brain as a pattern-bearing system, near-death reports that do not fit neatly in a single box, the possibility, still uncertain, that quantum effects can matter in living tissue, and the enduring fact that subjective awareness has not yet been fully explained, even in principle. And once we begin examining these puzzles more closely, the mystery becomes far stranger than it first appears. When physicists talk about mysteries, they often begin with something that sounds simple, almost innocent, a question about what it means to look. Because in everyday life, observation feels passive. You open your eyes and the world is already there. A table sits where it sits. A light is on or off. A coin is heads or tails, whether or not anyone checks. But at very small scales, in carefully controlled experiments, nature does not always behave that way. In quantum physics, the act of measurement is not merely reading a value, it is part of what defines the value. This is sometimes called the observer problem, and it is one of the most unsettling and yet carefully studied features of modern physics. Consider a familiar example, the double-slit experiment. A beam of particles, electrons for instance, is sent toward a barrier with two narrow openings. On the far side is a screen that records where each particle arrives. If you send electrons one at a time, they do not produce two simple piles, as tiny bullets might. Instead, the pattern that gradually appears has alternating bands, as if waves passed through both slits and interfered with each other. So far it is strange, but still manageable. You might say the electron behaves like a wave spread out in space until it hits the screen. But then the experiment becomes more peculiar. If you place a detector to find out which slit the electron went through, the interference pattern vanishes. You get the two piles, not because the detector physically blocks a slit, but because the information about the path is now available in the world. The system behaves differently when a measurement is made. This is not a matter of human eyes or human curiosity in the simple sense. The detector can be a lifeless device, a photodiode, a bit of matter that becomes correlated with the electron. And yet, the result changes. This leads us to a phrase that is used carefully in physics but can sound dramatic outside it: wave function collapse. In simple terms, a quantum system is described as a set of possibilities. Not just ignorance, not merely a hidden answer we have not found yet, but a mathematical description that combines multiple potential outcomes. Before measurement, the theory describes a spread, a distribution, a kind of structured uncertainty. After measurement, we get a single outcome, one dot on the screen, one definite record in a device. The description seems to shift from many possibilities to one actual event. That shift from a cloud of probabilities to a specific fact is what people loosely refer to as collapse. Now, to be precise, physicists do not all agree on what collapse means. Some treat it as a practical update, a change in our knowledge. Some treat it as a physical process, a real change in the system. And some interpret quantum mechanics in ways that avoid collapse altogether by saying all outcomes occur, but in separate, non-interacting branches. The mathematics works either way, but the meaning, the interpretation, remains open enough to keep philosophers and physicists awake at night. And so measurement becomes more than measurement. It becomes a question about what a fact is, about when a possibility becomes an event, about where the boundary lies between the quantum description and the classical world we live in. Is a measurement any interaction, any exchange of energy, any irreversible imprint on the environment? Or is it something else, something that has to do with information, with records, with what can, in principle, be known? These are not merely word games. They determine how we think about reality itself. Because if the universe needs some notion of measurement to produce definite outcomes, then we are forced to ask, what counts as a measurer? And this is where consciousness quietly enters the room, not as a conclusion, but as a temptation. Some interpretations of quantum mechanics, especially older popularizations, suggested that an observer, in the sense of a conscious mind, plays a special role. That reality is indefinite until it is perceived. That the mind somehow selects or crystallizes an outcome. This idea has an eerie appeal because it turns the ordinary relationship around. Instead of consciousness arising inside a finished world, the world would, in some sense, take shape around acts of awareness. But we need to be careful here, in the way a good scientist is careful, especially late at night, when imagination grows bold. Most physicists do not claim that consciousness causes collapse. Most working interpretations do not require a human mind to make quantum events real. A detector counts as an observer in the technical sense. A molecule in the air can count. The environment can count through a process called decoherence, where quantum possibilities become effectively separated and interference becomes practically impossible to observe. In this view, the world becomes definite, not because someone looked, but because information leaked into countless degrees of freedom, into heat, vibration, scattered photons, into the wider world. So why does the question linger? Why do serious researchers still find themselves circling it? Partly because, even if consciousness is not needed, the theory still leaves a strange gap in our understanding. Decoherence explains why quantum effects fade when systems interact with the environment. It explains why interference patterns vanish and why the world appears classical. But it does not, by itself, explain why one outcome is experienced rather than another. It explains the loss of visible quantum mixing, but not the arrival of a single lived result. And that subtle remainder, that quiet, unresolved point, is enough to keep the old fascination alive. Not because we want mysticism, but because we want clarity. We want to know what a fact is, and we want to know why we seem to live inside facts rather than probabilities. Now let's step gently from physics toward the mind. The brain is physical. It is made of cells, ions, membranes, neurotransmitters, electrical potentials. If you were to describe it as a machine, you could, and much of neuroscience does with enormous success. Yet some thinkers propose a very different role for the brain, not as a generator of consciousness, but as an interface, a filter, a limiter, a system that shapes and channels something more basic. This family of ideas is sometimes called filter theory or transmission theory, depending on the philosopher you read. The rough proposal is this: consciousness might not be produced the way heat is produced by a flame. Instead, consciousness might be more like a field of potential experience, and the brain is like a radio receiver, selecting, tuning, stabilizing a particular stream. Or the brain might be like a lens, constraining something broader into the specific personal perspective you call me. These are not mainstream scientific conclusions. They are speculative, they are difficult to test, and many neuroscientists argue, with good reason, that brain damage, anesthesia, and development strongly suggest that experience depends on brain function in a production-like way. When the brain changes, the mind changes. That is a powerful fact. Still, filter theories persist because they attempt to address a certain intuitive tension. If consciousness feels like a first-person presence, and if physics describes only structure and behavior, then perhaps, some say, the brain is not creating presence from nothing, but shaping it. Again, we should treat this as a philosophical perspective, not an established mechanism. It remains in the realm of interpretation, a way of organizing the unknown, rather than a settled map. But it leads to an interesting question, one that does not require any supernatural assumptions. It simply asks, what is identity, in physical terms? What makes you the same person across time? Your body changes continuously. Most of the atoms in you are exchanged with the environment over years. Your cells renew, your memories shift, some are lost, some are rewritten, some are quietly edited, each time you recall them. Your personality evolves. The you of early childhood and the you of today share a name and a story, but they are not identical, and yet you feel continuous. You feel like one thread running through all those changes. So what is the thread? Is it memory? But memory can be unreliable, and in some disorders, memory can fragment while the person still feels present. Is it a particular pattern of information in the brain's connections? But that pattern is dynamic, always being updated. Is it the body? But bodies change. And in thought experiments, we can imagine replacing parts slowly until almost nothing remains. At what point, if any, does the self stop being the same self? Philosophers have wrestled with this for centuries, not to be clever, but because identity is strangely slippery. We use the same word, same, in daily life, as if it is straightforward. The same chair, the same street, the same friend. But personal identity is not like a chair. It is not a static object. It is a process. A continuity of experience, a narrative, a pattern of perception and response that persists through change. And whether that persistence is a deep fact or a useful illusion is still debated. There is real uncertainty here, and it is honest uncertainty. Science can measure sleep, anesthesia, coma, brain rhythms, connectivity, the conditions under which consciousness fades and returns. But the question of what it means for an experiencing subject to remain the same is partly empirical and partly conceptual. It depends on what we mean by you. And this brings us very softly to the central mystery of experience itself. Subjective awareness, the fact that there is something it is like to be here, remains unexplained in any complete way. We can list the neural correlates, the regions and networks that reliably track attention, integration, reportability, self-modeling. We can build computational models that mimic aspects of perception. We can even build systems that speak about their own internal states. But none of this, on its own, answers the simplest question: why is there an inner light at all? Why is there a point of view? Why does information processing feel like something from the inside? Because of this, some scientists and philosophers have considered a possibility that sounds radical but is approached by some with careful seriousness. Maybe consciousness, or something like it, is not an add-on that appears only at high complexity. Maybe it is, in some minimal form, a fundamental feature of reality, like space, time, and mass energy. Not consciousness as we know it, not human thought, not language, but a basic ingredient that complex systems organize into rich inner worlds. One philosophical position along these lines is panpsychism. In its simplest form, it suggests that very small physical entities might have extremely simple forms of inner aspect, so simple we would not call it a mind in any everyday sense, but not entirely zero. Then, in complex systems like brains, these simple aspects might combine or coordinate into the unified experience we recognize. This idea has many versions and many problems. The combination problem, how tiny bits of proto-experience could form one coherent mind, is especially difficult. And panpsychism is not a scientific theory in the usual sense. It does not yet make clean predictions that separate it from other views. But some find it appealing because it refuses to treat experience as an impossible miracle, that emerges from pure mechanism. It tries to place experience somewhere in the basic inventory of the world so that it does not have to be conjured at the last moment. Other related ideas exist: neutral monism, where mind and matter are two ways of describing a deeper underlying reality, or informational approaches, where information is treated as primary and consciousness is linked to certain kinds of integrated information. Some of these proposals touch the edges of neuroscience and the edges of physics without fully settling into either. They are attempts to close the gap without pretending it is already closed. And so we arrive at a quiet tension. Quantum measurement raises questions about when possibilities become facts. Consciousness raises questions about why facts are experienced. The brain raises questions about whether it generates experience or merely shapes it. Identity raises questions about what it even means for a self to persist. None of this proves that death is anything other than the end of biological function. But it does suggest, with a calm kind of unease, that our deepest categories may not be fully stable. And if consciousness is not easily reduced to simple brain activity, then the nature of death may be more complicated than we imagined. That last thought can be held gently without turning it into a claim. Because the most responsible position is still the simplest one, that when the brain irreversibly stops, the experiences we associate with that brain stop as well. This is what the evidence most directly supports, and it is the assumption behind medicine and law and every ordinary plan we make for tomorrow. And yet, when we look carefully, we notice something subtle. Not a proof, not an escape hatch, but a persistent scientific discomfort with the way our theories are stitched together. Quantum physics, in its standard form, tells us how probabilities evolve. It tells us how to predict outcomes with astonishing precision. But it is strangely quiet about what an outcome is in the deepest sense. The equations, or if you prefer, the rules, give us a distribution. Then we open the box and find one result, a single pointer position, a single click, a single dot, and in our own case, a single experienced moment. This is one reason the observer problem never fully goes away, even when we remove any special role for minds. Because a measurement is not only a physical interaction, it is also a selection of one history out of many allowed histories. In some interpretations, that selection is only apparent. In others, it is real. But in every case, our lived world arrives as one line of events, one stream, one narrative. And we do not yet have a universally accepted explanation for why reality appears as a single stream to any particular point of view. So researchers keep exploring, carefully, without mysticism. Some focus on information, on what it means for a record to exist. A record in physics is not a diary, it is any stable correlation that can be copied and checked later. A pattern in a detector, a mark in a photographic plate, a change in a memory cell. When records spread into the environment, they become hard to erase, and that irreversibility seems closely tied to the world feeling definite. But then another quiet question appears. What does it mean for a record to be for someone? A camera can store data, a rock can carry a scar, but storing is not the same as experiencing, and this is where the mystery of experience returns as calmly as breathing. We can map the brain with increasing detail. We can see how anesthesia disrupts large-scale integration. We can observe how sleep changes the balance of signaling. We can even predict, in broad strokes, when someone is likely to be conscious or not. But prediction is not explanation. A model can tell you which circuits matter without telling you why circuits ever become a first-person world. This is why some thinkers float the idea that consciousness might be fundamental, not as a ghostly substance, but as a basic aspect paired with physical description. It is an attempt to avoid an uncomfortable jump from zero experience to full experience, as if a light suddenly turns on in a universe that previously had no inside. Panpsychism is one name for this tendency, but it is really a family of positions ranging from very cautious to very bold. Most of them are philosophical, not laboratory science. They do not yet give us a clean experimental switch that tells us this view is correct and the others are not. Still, the reason they stay on the table is not because they are fashionable. It is because the hard problem, the gap between function and feeling, still looks like a gap. And when a gap stays open, quiet minds keep walking around it, looking for a bridge. Now let's bring this back to identity, because identity is where these ideas become personal without becoming sentimental. When you say I, you're pointing to something. But what exactly? In neuroscience, the self is not located in one neat spot. It seems to be assembled from many processes: body sensing, memory, prediction, social modeling, attention, a sense of agency. The self is more like a committee than a single chairperson. And yet, the experience is unified most of the time. One center of gravity, one perspective. This unity is practical. It helps organisms survive. But philosophically, it is strange. Because if the self is a process, then continuity might be a matter of degree, not an on or off fact. Think of sleep or anesthesia. You lose awareness and later it returns. From the outside, it looks like a gap followed by a restart. From the inside, there's often no gap at all, only the next moment. So what guarantees that the one who wakes is the same one who slept? In daily life, we answer with confidence. Memory connects the chain. The body is continuous. The brain is still there, maintaining structure, even when experience is offline. But as thought experiments push, the certainty softens. If memory were copied perfectly into another brain, would that be you, or only a convincing twin? If your brain's activity paused and resumed, would you have been absent or simply unrecorded? Questions like this do not have scientific consensus answers, because they depend on what we decide the word you refers to: a particular physical system, a continuity of information, a continuity of experience, or something even more basic, a point of view that attaches wherever conditions allow. It gets slightly eerie, not because anything supernatural is implied, but because our ordinary categories begin to look like useful habits rather than ultimate truths. And in that quiet uncertainty, the topic of death takes on a new shape, not as a story about spirits, but as a question about continuity. If consciousness is produced by the brain, then death is the end of the producing process. If consciousness is filtered by the brain, then death could be a change in filtering rather than total annihilation. And if consciousness is fundamental in some minimal form, then death might be a rearrangement in how experience can be organized in this universe. None of these possibilities are established. They are ideas, carefully labeled, so we do not mistake curiosity for knowledge. But even that careful labeling does not remove the tension. Because the central fact remains, you are having an experience right now, and science, for all its power, does not yet fully explain what that fact ultimately is. And if consciousness is not easily reduced to simple brain activity, then the nature of death may be more complicated than we imagined. If we stay close to mainstream physics for a moment, and we try not to reach for metaphors too quickly, there is a concept that keeps returning, quietly, patiently: information. In everyday life, information sounds like something we store in books, or send in messages, or compress into files. But in physics, information has a sharper meaning. It is a way of describing what can be known about a system. Not just what you know right now, but what the universe, in principle, allows to be known. If I tell you where every grain of sand is on a beach and how fast each grain is moving, that description contains information. If I wipe it away, the beach still exists, but the specific pattern, the particular arrangement, has been lost to you. And physics asks a slightly unsettling question: lost to you or lost to the universe? Because many of our most successful physical theories treat information as something that cannot simply vanish. It can hide, it can spread out, it can become practically unrecoverable, but it is not supposed to be erased. This is one reason some physicists sometimes speak as if reality itself is informational, not as poetry, not as mysticism, but as a technical instinct. When we describe the world, we do not only talk about matter and energy, we also talk about states, about correlations, about what distinguishes one possible world from another. In quantum physics, this becomes especially prominent, because the state of a system is not just a list of positions and velocities. It is a structured object, encoding probabilities, relationships, constraints. And the strange part is, the state is not merely a human idea. It makes correct predictions. It behaves as if it is part of the machinery of nature. So a perspective emerges, cautiously, not universally accepted, but persistent. Maybe the universe is, at some deep level, a kind of information processing system. This family of ideas is sometimes called digital physics, or informational models of reality. The claims vary, and many are speculative. Some versions suggest that space and time might be made of discrete chunks like pixels, but far smaller than anything we can directly see. Some suggest the laws of physics resemble rules of computation, where the next moment follows from the present moment, as if the universe is updating itself. And some versions are more modest, saying only that information is as fundamental as energy, and perhaps more useful to talk about when we approach the edges of what we understand. Even in well-established physics, we already see the habit of treating information as physical. In computing, we often pretend information is weightless. But in reality, storing information requires a physical system, a magnetic domain, a charge, an atom in one configuration rather than another. Erasing information is not free either. In principle, it has an energy cost and it produces heat. That is not philosophy. That is physics. And it hints at something simple and profound. Information is not only a story we tell about matter, it is woven into what matter can do. So when we wonder about identity, about continuity, about death, it becomes tempting and also dangerous to translate the question into informational terms. If you are a pattern, if you depend on organization, then the next question is inevitable. What happens to patterns when the structure that hosts them collapses? To approach that, we can look at the most extreme collapses we know, black holes. Black holes are not just vacuum cleaners in space. They are regions where gravity becomes so intense that once you cross a boundary, the event horizon, the usual path back out, no longer exists. Inside that boundary, according to general relativity, everything is pulled inward toward a central fate, a place where our equations begin to break. Now here is the paradox, stated slowly, without drama, because it is already strange enough. Quantum physics is built on a principle that the evolution of an isolated system preserves information. You can scramble information, like stirring cream into coffee, but in principle the underlying information is still there, encoded in the precise details of the motion of molecules. General relativity, on the other hand, tells us a black hole can form, and then, over an enormous time, it can evaporate. Not by leaking from the inside, but through a subtle quantum process near the horizon, what is often called Hawking radiation. That radiation seems almost thermal, like heat. And heat, in everyday life, is what you get when the details have been blurred, when the fine structure has been washed away, leaving only broad averages. So imagine this, a star collapses, a black hole forms, it swallows complicated things, books, bodies, planets, entire libraries of microscopic detail, and then eventually, the black hole evaporates into a thin mist of radiation. If that final radiation contains no trace of what fell in, if it is completely featureless, then it seems the information is gone. Gone not just from our reach, but from existence. And that would be a problem, because it would mean quantum physics breaks in a very deep way. This tension is called the black hole information paradox, and it has been taken seriously for decades because it touches the foundations. Many physicists now suspect, strongly, that information is not destroyed by black holes, not because we have watched the process in a lab, we cannot, not yet, but because the best attempts to reconcile our theories keep pointing in the same direction. Information may survive, even extreme gravitational collapse, but in an encoded form. One idea is that information is stored, not in the interior, but at the boundary, on or near the event horizon, not as words carved on a surface, but as microscopic quantum degrees of freedom, a vast bookkeeping system, so dense we cannot visualize it. Another idea is that the radiation itself is not perfectly thermal, that it contains subtle correlations, exceedingly difficult to detect, but sufficient, in principle, to carry the information back out. In this view, nothing is truly erased. It is only dispersed, hidden inside complexity, like a message shredded into dust, then blown across a desert, still there, but no longer practical to reassemble. What does this reveal about the universe? It suggests that the universe may be, in a strict sense, a record keeper. Not a conscious one, not an observer with intentions, but a cosmos where the accounting is exact, even when the story looks like destruction. And once you accept that possibility, you start to notice how often loss in physics is just a name for too complicated to track. That brings us naturally to time. Because time is where information is usually felt, most personally. We do not experience time as an equation. We experience it as memory. The past feels fixed, partly because we can remember it, and partly because we cannot alter it. The future feels open, partly because we cannot remember it, and partly because it has not left traces yet. So there is an intimate connection between time and memory. A brain is a physical system that stores records, and those records are asymmetrical. You can remember breakfast, but you cannot remember tomorrow's sunset in the same literal way. Physics has a name for this asymmetry: the arrow of time. At the fundamental level, many physical laws work almost the same forward and backward, but the world we live in does not feel reversible. Spilled milk does not unspill. Ash does not reassemble into a log. A body does not naturally return to youth. This arrow is closely related to entropy. Entropy is often described as disorder, but a calmer way to say it is this: entropy measures how many microscopic arrangements fit the same overall appearance. A neat deck of cards is special. There are not many ways to have it perfectly ordered. A shuffled deck is typical. There are vastly many ways to be shuffled. So if you let systems evolve, they tend to move from special states to typical ones, not because the universe prefers mess, but because there are more ways to be typical than special. And as entropy increases, information about the fine details becomes harder to access. Not necessarily destroyed, but smeared out, diluted into the environment. This is why memory is physical. To remember something, you must create a stable trace, a pattern in a brain or a notebook or a computer. And to create that trace, you usually increase entropy somewhere else, often as heat. So the arrow of time, the direction you feel moving through life, is linked to where information is being stored and where it is being dispersed. Consciousness rides on top of that process. The conscious mind seems to assemble a now from incoming sensation, from stored memory, and from prediction. It is not just a spotlight on the present. It is a construction, a constantly updated model. That is why time can feel fast, when the model is smooth and slow, when attention is fragmented. It is why novelty can stretch time and routine can compress it. From the inside, the arrow of time is not just entropy. It is also narrative. Memory gives you a self that persists. Prediction gives you a self that aims. And this is where the topic of death becomes entangled with time, because death is often imagined as a hard stop. But physics, even without any spiritual additions, keeps showing us that hard stops are rare. Matter and energy are recycled, not metaphorically, literally. The atoms in your body were forged in earlier stars. Hydrogen from the early universe, carbon and oxygen made in stellar furnaces, iron made in violent ends. Stars are not eternal objects, they are life cycles. A cloud of gas collapses, a star ignites, it shines for millions or billions of years, transforming simple elements into heavier ones until fuel runs low. Some stars shed their outer layers gently, leaving behind dense remnants. Some die in explosions, supernova, seeding space with the ingredients for new planets and new chemistry. Over long time, galaxies evolve, stars are born and die, planets form, are reshaped, sometimes destroyed, and the debris becomes raw material again. There is no final landfill in nature, only rearrangement, and it is hard not to notice a parallel between cosmic recycling and biological recycling. In ecosystems, matter flows through bodies, through cells, through soil, through air, in loops. Life does not create matter, it borrows it, organizes it, and returns it. The pattern is the temporary miracle. The materials are ancient. So when we ask whether death could be a reset button, physics gives us a partial answer and a partial refusal. It says, your matter will be recycled, your energy will be transformed, but it does not yet say clearly what happens to the information that mattered most, the information that made you, you. And here we have to be careful, because information has multiple layers. Some information is obviously persistent beyond biology. A song can survive the singer, as vibrations once, and later as a record, and later as a pattern in someone's mind. A mathematical proof can survive its author because it can be instantiated again, in ink, in memory, in silicon. In computing, you can copy a file from one drive to another. The original arrangement of magnetic states is replaced, but the informational pattern persists. You could even destroy the original device, and the pattern remains somewhere else. In physics, we see something similar in a more abstract way. A wave can pass through different media, air, water, metal, yet the structure of the signal can be preserved. A message can be encoded in different physical forms, so long as the relationships are maintained. This suggests a distinction between the substrate, the particular physical stuff, and the pattern, the information, the organization of that stuff. Biology is a master of this. Your body replaces its material over time, yet the pattern of you, mostly, persists, not perfectly, but enough to sustain identity. So the question becomes quietly pointed. If information can move between substrates, if patterns can be preserved and copied and transformed, could identity, at least part of what you mean by identity, be informational? Not as a simple file, not as a digital ghost, but as a structured causal pattern, one that might, under some conditions, be continued, reinstantiated, or echoed, even if the original biological system ends. This is not an established scientific claim. It is a way of framing the mystery in a language physics already respects. And once you frame it that way, black holes feel relevant again, and entropy feels personal again, and the arrow of time feels less like a backdrop and more like a constraint on what kinds of continuations are possible. Because if the universe is, in some sense, an information-preserving system, then death is not only about matter stopping, it is about what happens to a pattern when its local machinery can no longer maintain it. Does the pattern simply dissolve into heat, into randomness, into irretrievable correlation? Or does it persist, in principle, encoded in the wider universe, too dispersed to gather, but not erased? We can sit with that question, gently, without forcing it into certainty. And we can end on one more thought, a thought that stays inside physics, but leans toward the edge. And if information truly cannot disappear from the universe, then the implications for consciousness become quietly unsettling. Consider what it would mean for the universe to be an exact record keeper, not a diary written in words, but a bookkeeping of correlations, of causes and effects, of which particle touched which and what phase relationships were established and what microscopic details were imprinted and where. In ordinary life, we talk about forgetting as if information can simply evaporate. But in physics, forgotten often means something more precise. The information is still present. But it has been distributed into so many tiny degrees of freedom that no realistic observer could gather it again, like a single drop of ink stirred into an ocean, still there, still affecting the exact state of the water, but not retrievable in practice. This difference between in principle and in practice is where many deep questions live. Thermodynamics, the physics of heat, teaches us that complex systems naturally move toward states that can be described with fewer macroscopic details. A room's air tends to even out in temperature. Perfume tends to spread through the space. A hot cup cools. We call these changes irreversible, not because the microscopic laws demand one direction, but because reversing them would require controlling an astronomical number of tiny motions with absurd precision. So when we say the world loses information, we often mean that information becomes inaccessible, buried under complexity. And this matters, because the idea of a reset button sounds like erasure, a clean slate. But if fundamental physics refuses true erasure, then a reset might look less like deletion and more like redistribution. The pattern stops being held locally and becomes something else, something wider, something scattered into the environment. Even your daily life contains small examples of this. When you speak, the air carries pressure waves outward. They fade, but they do not vanish instantly. They are absorbed into the microscopic jiggling of molecules, becoming heat. A moment later, that heat is shared and shared again, and soon the trace is effectively gone to any device you own. But it is not obvious that the trace is gone to the universe. It may be, in principle, encoded in unimaginably subtle correlations between molecules, between photons, between everything that interacted with that sound. This is the calm, eerie suggestion hidden inside a lot of modern physics. The universe may not have a trash bin, it has mixing. And now we can return, gently, to black holes, because they are the strictest test we know. If black holes really do preserve information, then even the most severe breakdown of familiar structure, even the collapse of a star into a horizon, is not a place where the cosmic bookkeeping ends. It would mean that physics, even at the edge where space and time behave strangely, still keeps track. Not in a way we can read, not in a way that comforts us, but in a way that is consistent and surprisingly stubborn. And this stubbornness leads to a larger framework, cosmology. Because if information is preserved locally, we are tempted to ask whether it is preserved globally, across the history of the universe itself. The universe has been expanding for a very long time. Space has stretched, light has traveled, matter has clumped into galaxies, stars have burned, entropy has risen. And yet the same question follows it all. Is the universe only changing form, or is it truly losing anything? Here, the scientific answer becomes more careful. We do not have a final complete theory that unites quantum physics with gravity in every situation. We have strong hints, compelling partial frameworks, and many consistent pieces, but not a finished map, so we should speak in layers. At the level we understand well, information behaves like something physical, something that can be stored, moved, transformed, and hidden, and that seems remarkably resistant to being destroyed. At the level we do not fully understand, the universe might still have exceptions, or the very meaning of information might need refinement. Still, the direction of the clues is interesting, because if the universe is an information processing system in any sense, then reset becomes an ambiguous word. A reset can mean wiping memory, or it can mean returning to an initial condition while the record of the process still exists somewhere else. In computing, you can reset a program, and yet the logs remain on a server. You can restart a device, and yet the network still carries traces, timing, metadata, side effects. The local system begins again, but the larger system remembers. Physics at times feels uncomfortably similar. Your body is a local system, a temporary island of organization, sustained by energy flow, by metabolism, by continuous repair. When that flow stops, the island does not disappear. It dissolves into the ocean of the environment, into soil chemistry, into air currents, into microbial activity, into heat radiated into space, into photons that travel outward, becoming part of the universe's ongoing accounting. So the question shifts, almost on its own, not does something survive intact like a photograph kept in a safe, but does anything about the pattern remain as a lawful continuation embedded in the causal fabric of the world? Does your existence leave information behind, not only in stories and artifacts, but in physical correlations, written into the universe at large? Mainstream physics can say, calmly, everything you do has physical consequences. Those consequences propagate. They may become unrecoverable to us, but they do not obviously become nothing. And that is where the topic of identity becomes delicate. Because identity, as lived, is not merely information in the abstract. It is a specific organization, a stable loop of perception and memory, a self-model updated moment by moment, a particular pattern that persists because the brain keeps remaking it. When the brain stops, that self-model stops being generated. From the inside, there is no longer a stream of now moments being stitched together. So if we wonder whether death is a reset button, we have to admit something plain. Even if information is conserved, conservation does not guarantee continuation. A pattern can be preserved as a trace without being preserved as an experience. A melody can be recorded without a singer hearing it. A brain state could be, in principle, describable without there being a mind still living through it. This is the quiet boundary line between physics and the felt world. And yet the boundary does not erase the question. Because if identity is partly informational, and if information is fundamentally conserved, then it becomes reasonable to ask cautiously, what would it take for an informational pattern to be reinstantiated, not as a memory in someone else, but as a functioning process again? Not as a claim, only as a question that physics allows us to pose. And if information truly cannot disappear from the universe, then the implications for consciousness become quietly unsettling. One way to respond to that unsettling feeling is to say something simple. Consciousness is what brains do. When the brain stops, it stops. That is the most practical assumption, and it fits much of what neuroscience can measure. But there is another possibility, one that keeps returning in late-night conversations between physics and philosophy. What if consciousness is not only a product, but also, in some sense, a feature of the universe itself? Not a ghost drifting through space, not a magical substance, just something like a basic ingredient. In physics, we already accept basic ingredients that we do not reduce further: space, time, energy, charge, fields, depending on which framework we use. So some thinkers ask, carefully, whether consciousness could be similar, not as a human personality, not as a memory, but as the simplest form of what it is like to be a system. This is not established science, but it is a serious philosophical proposal, and it is one reason the reset idea keeps its grip on the mind. In philosophy of mind, one of the best-known frameworks here is called panpsychism. The word sounds exotic, but the core suggestion is modest in a certain way. If matter can organize into brains that have experience, then perhaps matter already has a tiny spark of experience in simpler forms, and brains are what you get when those sparks become structured, integrated, and richly connected. Another nearby family of views is sometimes called neutral monism, the idea that the fundamental stuff of reality is neither mental nor physical, but something neutral, and what we call mind and matter are two ways of describing it, from different angles. And then there are approaches that treat consciousness as tied to information and integration. There is a framework called integrated information theory, which tries to quantify, in a principled way, how much a system is unified, how much it is more than separate parts running side by side. Some researchers find it promising, others find it unconvincing, and many treat it as a work in progress. There are also proposals like the idea of consciousness as a kind of internal model, a controlled hallucination, a brain's best guess about the world and the body, updated by sensory input. That line of thinking stays closer to standard neuroscience. But it still leaves an open question. Why should certain information processing feel like something from the inside? That question, often called the hard problem, is where the calm certainty can begin to thin. And this is important to say clearly, because the topic can become slippery. None of these frameworks are proven in the way we prove the existence of atoms, or the expansion of the universe, or the presence of neurons firing in the cortex. They are interpretations, attempts to connect objective description with subjective experience. They are debated vigorously, and in some circles, skeptically. Still, even a debated interpretation can be useful, because it changes what we are allowed to imagine without changing what we claim to know. And that brings us back to the reset hypothesis, not as a promise, not as a comfort, just as a metaphor that physics makes difficult to dismiss completely. When most people hear death, they imagine termination, a hard stop, like switching off a light. The reset metaphor suggests something different. Not that you continue smoothly, but that the local process ends, and yet the universe as a larger system still contains the conditions and laws that once produced you. In a reset, the program stops, memory clears, the screen goes dark, but the machine is still built from the same physics, and the same kinds of patterns can run again. Now for identity, this is where things become delicate, because you are not your atoms. Your atoms are replaced over time. You are not even a single static pattern. You are a pattern that keeps changing while maintaining continuity. In everyday terms, your identity is carried by memory, temperament, habits of attention, the particular way your brain ties past to present. In more analytical terms, identity is a dynamic informational pattern, a self-sustaining process implemented in biological matter. If that pattern is what matters, then the question becomes, could an equivalent pattern ever appear again? Not in the sense of someone resembling you, or sharing your genes, or reading your diary, but in the stricter sense that the same informational organization, the same causal structure, is instantiated again in a physical system. In principle, physics does not forbid patterns from repeating. It rarely guarantees it, but it does not forbid it. We see repetition everywhere in nature, crystals forming similar lattices, storms forming spirals, stars following similar life cycles. Patterns return because the laws are stable and the conditions recur. So could the pattern called you re-emerge? Here the honest answer is, we do not know. There are some cautious theoretical routes people consider. One is purely statistical and deeply strange. In an unimaginably large universe, with enough regions, enough matter, enough time, it becomes less impossible for complex arrangements to occur more than once. Not likely, not soon, but not strictly impossible. Another route is through cosmic cycles. Some cosmological models, speculative but mathematically explored, imagine the universe not as a single beginning and end, but as a sequence, expansion, contraction, renewal, or as a kind of bouncing process. Most cosmologists treat specific cyclic models with careful skepticism because the evidence strongly supports an expanding universe with a hot, dense early phase, and because cycles raise hard questions about entropy and initial conditions. Still, the broader idea matters for our theme. If the universe has repeated phases, or if there are many universes in a larger structure, then there are many chances for consciousness to arise, again and again, in different forms, in different histories. Not necessarily you, but mind, as a recurring phenomenon. And if consciousness is not an accidental oddity, but something that emerges naturally from certain kinds of complexity, then it may be widespread in time, even if it is rare in any given place. This is what we might call cosmic scale identity, not the persistence of your personal story, but the repeated awakening of experience itself. The universe runs its processes, and under the right conditions, it opens its eyes. That phrasing is poetic, yes, but the scientific core is simply this. If experience arises from universal processes, then wherever those processes occur, experience may occur. And then comes the unsettling implication, one that should be held gently, because it is easy to misunderstand. If consciousness arises from universal processes, and if the laws of physics are stable, then the boundary between lives may be less absolute than we assume, at least in the space of possibilities. Not in the sense that you are secretly inhabiting other bodies now. That would be an extra claim, and we do not have evidence for it. But in the sense that the universe might not treat your specific conscious moment as a unique, never repeatable event, in the way our emotions want it to be. That challenges traditional thinking in two directions at once. It challenges the comforting idea that you are guaranteed to continue as yourself. And it also challenges the bleak idea that your kind of experience is a one-time spark that vanishes into permanent nothing. Instead, it suggests a third picture. A universe where conscious processes ignite when conditions allow, fade when conditions fail, and may ignite again elsewhere, without memory, without continuity, and yet not entirely unrelated because the laws that generate them are shared. That picture can feel eerie because it loosens the grip of the personal narrative. It asks us to consider that the universe might generate many centers of experience, and that being one of them, right now, is not a metaphysical privilege, but a physical occurrence. And yet, scientists remain cautious, because science is not the art of what we can imagine. Science is the discipline of what we can test. At the moment, we do not have experiments that can confirm panpsychism, or show that consciousness is fundamental, or demonstrate that an identity pattern can truly reinstantiate in a way that counts as survival. We can measure brain activity, correlate it with reports, disrupt it with injury or anesthesia, and observe, with increasing detail, how experience depends on brain function. That is strong evidence that whatever consciousness is, it is intimately tied to physical processes. But whether consciousness is only an emergent product or also a fundamental aspect is still unresolved. It is the difference between two kinds of statement. An established scientific statement sounds like, when the brain is damaged in certain regions, specific abilities and experiences are altered. When anesthesia changes neural dynamics, conscious report disappears. When sleep shifts brain states, the structure of experience changes. A speculative statement sounds like, therefore consciousness is identical to neural computation in the final metaphysical sense. Or, therefore consciousness is a fundamental field of nature. Those therefores are where caution is required, and the caution is not indifference. There is active research, ongoing, careful, into the neural correlates of consciousness, into how the brain binds information, into why some processing becomes reportable and vivid, and other processing stays silent. There are studies of anesthesia, coma, dreaming, split brain cases, disorders of self-perception, and the subtle timing of awareness. There are computational models and competing theories and debates that can be surprisingly polite, given how strange the subject is. So we can hold the reset hypothesis as a metaphor with constraints. Death in biology is an end of a process. Death in physics is a transformation of matter and energy. Death in information terms is the dispersal of a pattern. And the question is whether dispersal is the same as erasure, or whether the universe's lawful evolution could ever gather something similar again, not as a guarantee, not as a message, only as a possibility that cannot be dismissed by simple intuition. And yet, even if none of these possibilities prove correct, the mystery of consciousness remains one of the deepest questions science has ever faced. When scientists say that, they are not being evasive, they are being precise. Consciousness is a real phenomenon because it is the very thing in which all measurements and questions appear, and yet it is also strangely private, accessible from the outside only through behavior, through language, through signals in the nervous system, through indirect footprints. This makes it different from most objects in physics. A planet has a mass and an orbit whether or not anyone is there to notice it. But consciousness is the noticing itself. So the careful late-night question becomes, what kind of thing is consciousness, if it is so tightly tied to matter and yet not easily captured by the usual descriptions of matter? Some philosophers and a few physicists have wondered whether we are missing a category. Not a supernatural category, just an incomplete inventory of what the universe is allowed to be. In that view, consciousness would be a fundamental property, not meaning that rocks have human thoughts, not meaning that electrons have emotions, only meaning that at the most basic level there may be a very simple inside paired with the outside that physics describes. This is one reason panpsychism keeps returning, not because it is comforting, but because it offers a route around a puzzle. If consciousness appears suddenly only when matter reaches a certain complexity, then we must explain how something so different from charge and mass emerges from charge and mass. But if the raw ingredient is already present in extremely minimal form, then complex minds are not a miracle. They are an organization. Still, that is an interpretation, not an established result. And it stays controversial because it is difficult to test. You cannot put a tiny spark of experience in a container and weigh it. You cannot point a telescope at the inner life of a distant system. So responsible thinkers keep a boundary line. They treat these frameworks as conceptual tools, tools that might help us speak carefully about what the data could allow without pretending the data already says it. Now, with that boundary in place, the reset metaphor becomes clearer. When we picture death as termination, we are thinking like an individual organism. A life begins, a life ends, and the story closes. But physics often thinks in processes and in patterns. A candle flame is a pattern. It is really a stable process fed by fuel, oxygen, heat, and shaped by chemistry. When the fuel is gone, the flame ends. We do not usually say the flame has traveled somewhere else. We say the process stopped. And yet the laws that made the flame possible did not vanish. The conditions changed. Now imagine, cautiously, that a conscious mind is also a process. Not just a thing that sits in a skull, but a self-sustaining pattern involving perception, memory, prediction, and a steady reference to a body. When that biological support fails, the process ends. But if the universe can generate such processes at all, then the possibility space remains open. Not as a promise, not as a plan, just as a statement about lawful patterns. This is where identity becomes the delicate point again. Because when people say reset, they often mean, I will come back. But from an analytical standpoint, a reset does not preserve your biography. It does not carry over the continuity you feel from yesterday to today. It only suggests that the kind of pattern that produces an inner point of view might occur again, somewhere, sometime, under the right conditions. Whether that counts as you depends on what you mean by you. If you means your memories, then continuity is central. If you means a particular informational structure, a specific causal pattern, then the question becomes whether that pattern could reappear. Here we should be calm and honest. We do not know whether the exact causal pattern that is your mind could ever be repeated. Even in principle, it may depend on details we do not yet understand. Some philosophers argue that a perfect copy would still not be you, because identity is not just structure, but a continuous thread. Others argue that continuity is itself a type of structure, and that if the structure is truly the same, the distinction becomes unclear. Science at the moment cannot settle that debate. Science can tell us that continuity in brains depends on ongoing physical activity. Sleep alters it, anesthesia interrupts it, injury can fracture it, and that strongly suggests that the personal self is not an indestructible essence. It is a maintained pattern. The reset hypothesis, in its most careful form, does not claim that essence persists. It asks a narrower question. If the self is a pattern, does the universe ever repeat patterns at scales that matter? We already know the universe repeats patterns at small scales constantly. Every hydrogen atom is remarkably similar. Every electron, as far as we can tell, is indistinguishable from every other. Nature has a habit of making copies when the laws are simple and stable. But a mind is not an electron. A mind is astronomically intricate and constantly changing, so repeating it would be far harder. That is why the most grounded version of re-emergence is not personal immortality. It is the repeated arising of consciousness in general. Cosmic scale identity, not as one life returning, but as experience itself appearing again and again, in different species, on different worlds, in different cosmic eras, perhaps in different universes, if such things exist. And in a cyclic cosmology, if cycles were real, then there could be repeated opportunities for complex structures to form, not necessarily the same person, but the same kind of awakening. There is a quiet parallel here. Biology has cycles, birth, death, recycling of matter, the same atoms passing through soil, leaf, lung, ocean. Cosmology has cycles in some models, or at least repeating motifs. Stars ignite, stars fade, elements are forged, dispersed, new systems form from old remnants. The matter does not remember, and yet the universe keeps making organized islands of complexity. In that sense, even our most ordinary scientific story already contains a soft version of reset, not for the individual, but for the process. And this leads to the unsettling implication, the one that sits quietly in the back of the mind. If consciousness arises from universal processes, and if the universe is vast enough, old enough, or generative enough, then the boundary between lives may not be a sharp metaphysical wall. It may be more like a boundary between storms. A storm forms, maintains itself, dissolves, later another storm forms. They are not the same storm, but the atmosphere that produces them follows the same rules. To say this calmly is not to diminish a human life. It is to place it within a wider context that is both elegant and a little eerie, because it suggests that what you call being someone might not be a singular miracle. It might be something the universe does whenever certain thresholds are crossed. That idea can challenge traditional thinking in a way that is oddly symmetrical. It can weaken the hope of personal continuation, and it can also weaken the despair of permanent, total exceptionality, the fear that consciousness was a fluke that will never happen again. It replaces both with a quieter uncertainty, a reality where consciousness is not guaranteed, but also not unthinkable. A reality where the universe may be more generous with experience than our daily perspective suggests, even if it is not generous with memory. And then, because this is the Sleepy Cosmos channel, we come back to scientific caution, like returning to a familiar shoreline. None of this is proven. There is no measurement today that tells us consciousness is fundamental. There is no experiment showing that an informational identity pattern reinstantiates after death in any way that counts as survival. There is no accepted physical theory that includes consciousness as a basic field alongside the others. What we do have are strong correlations between experience and brain state, and a growing toolkit for probing those correlations with increasing precision. We have ongoing debates about what kinds of information processing are sufficient, about what role attention plays, about whether consciousness is widespread or rare, about whether it is graded or all or nothing, and about whether subjective report captures the whole phenomenon or only part of it. And we have the deep fact that the universe is made of lawful structure, and lawful structure can be repeated, even when the details are daunting. So we keep the boundary clear. Established science tells us that conscious experience depends on physical processes, and that death ends the biological process that supports your present stream of awareness. Speculation asks what that dependence ultimately means, and whether nature's ability to generate experience could imply recurrence, in some form, across the vastness of time. We can think about it without turning it into a doctrine. We can let it be a carefully held hypothesis, a way of noticing how much we still do not understand about the most familiar thing we have ever known, our own awareness. And yet, even if none of these possibilities prove correct, the mystery of consciousness remains one of the deepest questions science has ever faced. There is a gentle lesson that keeps returning. Whenever you spend enough time with science, not that we know everything, but that every new layer of understanding quietly reveals another layer beneath it, and beneath that, another. For most of human history, the sky looked like a dome, stars pinned to it like distant lanterns. Then we learned the Earth is a sphere, and it moves. Then we learned the sun is a star, and the stars are suns. Then we learned the galaxy is only one. In a population so large, the mind begins to lose its grip on quantity. Science does not only answer questions, it also shows us how many questions we did not know to ask. And even in areas where our knowledge is strong, the edges remain strangely soft. We can describe how gravity behaves with extraordinary precision and still debate what gravity truly is in the deepest sense. We can map the chemistry of a cell, track the signals of neurons, measure the flow of energy through tissue, and still not know why any of that should be accompanied by an inner point of view. That is not a failure in the simple sense. It is the normal shape of honest inquiry. Scientific knowledge evolves because it must. It is not a monument carved once and protected forever. It is a living practice, built from careful observation and corrected by the next observation and refined again. A model works until it does not, or until something more precise arrives. A theory is trusted, not because it is sacred, but because it survives contact with reality again and again. And sometimes, what changes is not only the details, but the very frame of the question. We used to ask what the sun was made of in the way you might ask what a fire is made of. Then we learned about nuclear fusion, and the question became how the laws of matter and energy permit a star to shine for billions of years. We used to ask what life was, as if it were a substance. Then we began to describe it as organized chemistry, as metabolism, as self-maintenance, as information and selection operating in matter. This is why scientists, at their best, carry a particular kind of humility, not the humility of pretending to know nothing, but the humility of remembering how often certainty has been temporary. It is a quiet discipline to hold the current explanation firmly enough to use it, and lightly enough to revise it. And when the topic is consciousness, that humility becomes more than good manners. It becomes necessary. Because consciousness is the one thing you cannot step outside of to examine from the outside. You can measure brain activity, but the measurement is not the feeling. You can correlate attention with perception, but the correlation is not the redness of red, or the taste of salt, or the simple fact of being here. And still, questions about consciousness follow us. Not only because they are intellectually interesting, but because they touch the most personal assumption we carry, that there is a someone behind the eyes. It is not surprising that every culture develops stories about what happens to that someone, because the idea of a first-person perspective simply ending has a peculiar emotional weight. Not always terror, sometimes only a thin, cool unease. Like standing at the edge of a dark ocean at night and realizing how far it goes. And yet, the fascination is not only fear, it is also curiosity, the stubborn desire to understand what we are. This is where science and philosophy quietly meet. Science asks, what can be measured, what can be predicted, what is consistent and testable? Philosophy asks, what do we mean by the words we use? What counts as an explanation? What is a self? What is identity? What is experience? And what would it even mean for an answer to be complete? When the subject is consciousness, you need both temperaments. You need the patient instrument builder and the patient concept builder. You need careful data and careful definitions, and you need the willingness to live with partial clarity for a long time, because mystery is not only an obstacle. In a strange way, mystery is a fuel. The fact that we do not understand what consciousness is part of what drives neuroscience forward, and psychology, and computer science, and the study of sleep and anesthesia, and the careful mapping of how brain injury changes experience. We learn by tracing the outline of what we cannot yet see directly. A good mystery, handled properly, does not invite wild conclusions. It invites better questions. It invites experiments that separate what seems plausible from what is merely comforting or merely frightening. And slowly, over time, the circle of what can be said responsibly expands. Still, As we explore these ideas, it can be calming to remember where we are in the larger story. Human life feels enormous from the inside, and in a meaningful sense, it is. A single conscious moment is the universe doing something rare and delicate, assembling matter into a pattern that can notice itself. But on the cosmic timeline, a human lifetime is brief, not insignificant, just brief. The universe is old enough for whole galaxies to collide and settle, for stars to be born and die, for elements to be forged, for planets to cool, for chemistry to find repeating cycles, for life to climb slowly toward minds. Your body, calmly speaking, is part of that long process. The atoms in your blood were not manufactured for you. Most of the elements heavier than hydrogen were formed in stars, in their interiors, and in their depths. Carbon in ancient stellar cores, oxygen in massive stars, iron in the violent ending of suns far larger than our own. Those atoms were scattered, mixed into clouds, gathered again, became rocks, oceans, air, became cells. And the energy you use each day has its own long history. Sunlight is not just brightness, it is a stream of energy released by fusion in the sun's core, taking an unimaginably long time to wander outward, then crossing space to fall on leaves, or skin, or water, and being captured by chemistry. Even the heat your body gives off is part of a vast flow, energy moving from concentrated forms into more spread out ones, a universal tendency that shapes everything from weather systems to galaxies. So when we talk about resets, we should be careful, but we can also widen the view. In the most established sense, nature is already a kind of recycler. Matter circulates through star and dust, through planet and ocean, through organism and soil, through breath and bloodstream, again and again. The pattern of a person does not persist in the same way a rock persists, but the ingredients do, and the laws that guide those ingredients remain. There is continuity, not necessarily of personal identity, but of the cosmic process itself. This is not meant to be a consolation or a cold dismissal. It is simply a perspective. You are not a visitor in an alien universe. You are a local phenomenon, a temporary organization of the same reality that makes nebulae glow and makes stars rotate and makes atoms hold together. That continuity can feel quieting, especially when the mind starts to press on the question of endings. Because uncertainty does not have to be a doorway to fear. It can be a doorway to wonder. When we admit that science has not yet solved the hard problem of consciousness, when we admit we do not know whether death is a full stop, or whether nature has deeper forms of recurrence we have not recognized, we are not forced into panic, and we are not forced into fantasy. We can rest in the middle, calmly, not as a compromise, but as an accurate description of our current position. There is a particular peace in saying, I do not know, and I will not pretend, and then noticing that the not knowing does not collapse the world. The stars still shine, your breath still moves in and out, steady, automatic, ancient. The mind is allowed to hold a question without squeezing it into an answer too soon. In fact, this ability may be one of our strengths. Curiosity. Not frantic curiosity, not the kind that grabs at certainty, but the patient kind, the kind that can watch and learn. Curiosity is what makes us set up experiments that take decades. It is what makes us build instruments to detect faint signals from deep space or to measure subtle patterns in the living brain. Curiosity is what lets a species that evolved to survive on a savanna ask questions about time, identity, and the strange fact of being aware at all. So tonight, as we return to the central question that has been hovering behind everything, what if death is just a reset button? We can say something precise and something honest. Science, as it stands, does not confirm that idea. The strongest mainstream evidence suggests that your present conscious stream depends on the functioning brain, and that when the brain permanently stops, that stream stops. And yet, science also has not fully explained what consciousness is, or why it appears at all, or whether it could arise again in forms we would recognize as meaningful. We do not yet know which aspects of experience are tied to unique history, and which might be reproducible given the same kinds of physical conditions. We do not know whether the universe contains principles we have not discovered, principles that would reframe what we mean by an ending. So the most responsible place to land is not certainty. It is a quiet, wakeful curiosity. To keep living our lives, to keep caring for each other, to keep building knowledge, while allowing the mystery to remain a mystery, for now. And maybe that is enough, not an answer, but a steady way of holding the question, as if you were holding a small, warm object in your hands, not squeezing, just noticing its weight. And perhaps, somewhere in the vast silence of the cosmos, the answer to this question is already waiting to be discovered. If you listen carefully to that last thought, you can hear two things at once, a limit and an invitation. The limit is simple. We are a young species studying an old universe with senses that evolved to notice predators and fruit and weather, not to intuit quantum fields or the true shape of time. So we build extensions of ourselves, telescopes, particle detectors, brain scanners, mathematical models, and we do something quietly extraordinary. We let nature answer back. But even then, the answers arrive through narrow channels, a shadow in starlight that suggests a planet, a faint ripple in a detector that suggests a distant collision, a pattern of activity in a cortex that suggests an intention. Science is powerful and also inherently incomplete, not because it is weak, but because the universe is deep, and because every measurement is taken from within the universe by observers who are themselves part of the system being studied. This is one reason the most honest scientific voice often sounds like this. Here is what we know. Here is what we suspect. Here is what we do not know yet. Not as a hedge, but as a map. And the map changes. In the past, we were confident that space and time were fixed and separate, until relativity made that confidence feel slightly naive. We were confident that physical events could be described without fundamental randomness, until quantum physics introduced probabilities into the bones of our predictions. We were confident that life required a special essence, until chemistry and evolution showed how complexity could accumulate. Again and again, knowledge moves forward, and the movement itself is a reminder that our current picture is never the final one. That is not unsettling in a dramatic way. It is simply sobering, and it can be strangely comforting. Because it means we are not expected to have the last word, only the next careful word. And still, with all those limits, the mystery matters. It matters because consciousness is not a side topic in human life. It is the stage on which everything appears. Every fear, every hope, every memory, every plan, every piece of science anyone has ever done appears inside experience. So when we ask what consciousness is, we are not asking about a distant object like a comet. We are asking about the medium through which comets are known. That is why these questions keep returning, in laboratories, in philosophy seminars, in quiet bedrooms late at night, when the mind notices itself noticing and wonders what will happen when that noticing stops. Science and philosophy become companions here, not rivals. Science offers constraints, what brain damage does, what anesthesia does, what sleep does, how development changes a mind, how certain neural circuits seem necessary for wakeful awareness. Philosophy offers clarity about the concepts, what we mean by identity, what counts as survival, whether continuity requires memory, whether a perfect copy is you or only a twin, and what kind of answer would actually satisfy the question. Without philosophy, we can collect endless data and still talk past the point. Without science, we can build elegant ideas with no anchor. Together, they keep the mystery productive, not as a fog to hide in, but as a frontier to approach with careful steps. Because mystery, when treated respectfully, is not a wall, it is a direction. It is what makes people design experiments with patience and restraint, what makes them argue about definitions for years, what makes them admit when a result is ambiguous and then try again. Not to fill the unknown with comforting stories, and not to fill it with despair, but to learn what the universe will allow. And while we do that, it helps to remember what kind of place we live in. You are alive in a universe that has been changing for a very long time, and will keep changing long after individual lives end. Our planet formed from older material, grains of dust from earlier stars. And over time, those grains assembled into landscapes, oceans, atmosphere, and then into systems that could copy themselves, compete, cooperate, adapt, and eventually become nervous systems, and then minds. So in the most literal sense, your life is not separate from the cosmic process. It is one expression of it. The matter in you does not sit still. It exchanges constantly with the world. You breathe in oxygen that was once part of the sea, or the air over a forest, or the lungs of another animal. You drink water that has traveled through clouds and rivers and roots. The carbon in your cells may once have been in a leaf, then in soil, then in a microbe, then in the atmosphere again, circling with quiet persistence. Even now, as you listen, some atoms leave you with every exhale and others enter. In a calm, steady way, you are already participating in a kind of continuous exchange, a gentle recycling that does not wait for an ending. Zoom out farther, and the cycling becomes grander. Stars burn through their fuel and change their chemistry. They swell, they shed their outer layers, they collapse, and in those processes they manufacture the ingredients of planets and oceans and nervous systems. Galaxies stir and merge, and distribute gas and form new generations of stars, over timescales so large they can make a human life feel like a flicker. Not meaningless, just brief. And within that vast duration, life appears to be one of the universe's methods for making complexity, and perhaps, in rare cases, for making awareness. That continuity between you and the cosmos is factual before it is philosophical. It is chemistry, thermodynamics, astronomy, but it can also become a kind of quiet medicine for the mind because it reframes the feeling of isolation. You are not a stranger here. Even your most private thoughts depend on the same stable laws that guide planets in their orbits. And if that is true, then uncertainty itself can be approached differently. When we do not know what happens at death, we can notice two temptations. One is to demand certainty and accept the first story that makes the mind relax. The other is to demand certainty and accept the bleakest story as if it were proven. Both are understandable. Both are forms of the same discomfort, the discomfort of leaving a question open. But leaving a question open is not the same as leaving it empty. An open question can be held gently, like a specimen jar that contains something delicate, not to trap it, but to keep it safe until it can be examined with better tools. There is peace in that. Not the peace of a final answer, but the peace of intellectual honesty. To say, I will not pretend to know what I do not know. And I will not let the lack of certainty poison the present moment, because unanswered questions can inspire wonder instead of fear if we let them. Wonder is not denial. Wonder is simply the mind recognizing a gap between its current map and the territory, and feeling drawn forward rather than crushed. It is the same emotion that kept early astronomers watching the sky, the same emotion that keeps researchers patiently repeating measurements, the same emotion that leads a person to sit quietly with their own existence and feel, for a moment, the strange fact of being here. Curiosity, in that sense, is not a hobby. It is a human strength, a way of staying awake without becoming frantic, a way of walking up to the edge of the known and looking out without falling. And so, we return, gently, to the question that started all of this. What if death is just a reset button? It is a question with many layers, a scientific layer about brains and information and what is required for experience to occur, a philosophical layer about what counts as you, whether continuity is memory or character or something deeper, and a personal layer about how a finite mind lives inside time and tries to make peace with endings. At the moment, science has not solved it. We have strong evidence that consciousness, as we know it, depends on the living brain, and that when the brain is permanently gone, the familiar stream of experience does not continue in any detectable way. We also have strong evidence that the universe is stranger than common sense suggests, that time behaves oddly, that matter is not as solid as it feels, that information has a deep role in physical law, and that our understanding of consciousness itself remains incomplete. So we stand in an honest place, between knowledge and ignorance, between what is established and what is still mysterious. Not helpless, just unfinished. And perhaps that is the natural condition of thinking beings in a universe like this, to understand some things clearly, and to live with other things as open questions, not as threats, but as invitations to keep observing, keep reasoning, keep refining, while also living tenderly inside the brief window we have. If death is not a reset, then the meaning is here, in the one life we can verify. If there is some form of recurrence, some deeper pattern we have not detected, then meaning is still here, because whatever comes next would be built from what is true now. Either way, the present moment remains real. Your breath, your attention, the quiet machinery of your body, the slow turning of the earth, all of it continuing. without needing permission from our answers. So we end, not with certainty, but with a steadier thing, a calm respect for the boundary of what we currently know, and a quiet affection for the mystery beyond it. And perhaps, somewhere in the vast silence of the cosmos, the answer to this question is already waiting to be discovered.